This is the video for Mod 3 Lesson 7, Writing Equations and Graphing Polynomial Functions. In this lesson, we're going to look at how to use the roots, or we sometimes call them zeros, to find the equation for a polynomial function. And we're also going to look at sketching functions on a coordinate plane. So the first one, example, or this is just kind of a preview of what we're going to be doing. We saw in previous videos that factored form can give us the number of roots and identify those roots for us. So for example, this equation, we have it in factored form. If the question is what are the roots, you're just taking the opposite of what's in those parentheses. So we have 2, 0, negative 1, 0, negative 3, 0, and this one we can't really just make it negative 1. We might find that we have to solve it a little bit, right? Because really what we're doing is we're taking each parenthesis and setting it equal to 0. Because a root is an x-intercept, so that's basically when y is equal to 0. So we're seeing what makes these parentheses 0. So when I multiply it out, I get 0 for y. So that's really what we're doing when we're taking their opposite. But if there's if we have to do a little solving, we might have that one is a negative 1/2, 0. The degree, we end up having 4, so it's a least degree of 4. And the leading coefficient, if I was to multiply all this out, we can actually see that we would end up getting a degree actually of 2. And we'll talk a little bit about that in the next couple when we multiply it out. But if I multiply all of the first terms, that's going to give me my leading coefficient, and it would be a lead coefficient of 2. All right, so in this video, we're going to find instead of factoring, we're going to be multiplying polynomials like we saw way back in the first video for this mod. Where we multiply two binomials, we're just going to have more than 2 that we're working with. So the first thing we might do is if we're going to have to do a sketch eventually, and we'll multiply this out at the end, is that when we take our opposite or set each of these to 0, because that's really what we're doing here. I'll even write that step just so you know where that's coming from. If I set each of these to 0, I would get a negative 4. I would get a positive 3. And then this one, when I set it to 0, I would actually get a positive 3/2. Or that's the same as 1.5. And so we actually have 3 zeros for this problem. I'm gonna list them out here. Negative 4, 0, 3, 0, and 1.50. So that's not the only part they're asking for in the problem. We're eventually going to have to sketch it out. But basically, we have to write this now in standard form. So that means we have to multiply all of these binomials together and get an equation that's in standard form. And the nice thing is that sometimes tells us even our y-intercept in standard form, but they're really asking for 2 different things for this problem. So I'm first going to pick these first 2 binomials and multiply them out. And so with this question, the hardest thing is it's just kind of a little tedious. It's not anything that's brand new, but we have to multiply 3 things now instead of 2. So I have x squared minus 3x plus 4x minus 12. And so I get here x squared plus x minus 12. And now I have to, though, take it one step further. I have to take x squared plus x minus 12, and I still have this 2x minus 3 I have to multiply through. Because, again, I started with three different parentheses. I have to multiply them all out. So I'm going to go ahead and do just that. So I'm going to multiply. I get here, and I'm going to write this in like kind of little sections here. So it's x squared times 2x. Remember, we have to add the exponents, so I get 2x cubed. X squared times negative 3, I get negative 3x squared. I'm now going to go to the next piece, which I have to multiply 1x to everything in that second parenthesis, right? So x times 2x is 1x squared. I'm sorry, 2x squared. 1x times negative 3 is negative 3x. And then the last piece, I got to multiply this negative 12 to everything. So negative 12 times 2x is negative 24x. Negative 12 times negative 3 is positive 36. And now I'm just going to combine all my like terms. So I have 2x to the third. I'm going to cross that out. Negative 3x plus 2x squared is negative x squared. Negative 3x minus 24x is negative 27x. And then positive 36x. Or 36, not x. So I'm going to write a y equals in front because this is still a function. And now there's a couple things I can see when it's in this form. I see my and we could have found the leading coefficient before we did all that too, but our leading coefficient is 2. This is a degree 3, so I know it's going to look something kind of like this when I sketch it. It's a positive leading coefficient, so I know this is the direction it's roughly going to go. My y-intercept is a positive 36, so I might fit that on my graph. I might not be able to fit that on my graph. And then I already had my roots from the beginning of the problem. So once I multiply that out, I'm going to go ahead and sketch this. So I have negative 4 as a root. So I'm going to plot my roots first. So I have negative 4. I have 1.5. So I'm maybe going to plot 2, 3, 4. So 1.5 is roughly here. And then I get a positive 3. I know, so those are my 3 roots. I know it's roughly going to have this shape. The y-intercept is a positive 36, so maybe if I want to put a little 36 here, again, this isn't really to scale, but you know, it's just kind of a sketch. And I'm just now going to do my very, very, very best to try to go through these, what we call them the critical points, right? So these are like my points I want to make sure I go through following like this S shape. So I'm maybe going to go something like this. Try to hit that y-intercept I plot. I know it's going to go down. And maybe up. And it kind of roughly hits this, looks something like this, right? Where it goes like this. And I did my best though. Notice I clearly marked my intercepts and I marked maybe my y-intercept. It has the degree 3. And it's going, you know, in this direction with negative infinity and positive infinity. So we're not concerned the graph looks perfect. We're just concerned you're hitting those points and it's following the degree shape of a degree 3. In this example, we're going to write the equation in standard form and then graph. So first, let's write the equation in standard form, and then we'll go ahead and talk about the graph. So the first thing you're going to notice here is if we write this out, we actually have quite a bit that we have to multiply. We can't distribute the x to the x minus 2 because we do have a squared here. So we might take this x minus 2 squared and go ahead and multiply that out first. So I'm going to go ahead and take this first piece and multiply it out. And so when we go ahead and distribute, we're going to get x squared minus 2x minus 2x plus 4, or x squared minus 4x plus 4. We then have the other pieces that we can bring down. And we have an x that we can distribute inside. So now that we got rid of that exponent on the outside, so x cubed minus 4x squared plus 4x. And now we have that x minus 3 that we still, or x plus 3 that we still have to distribute. And then we just kind of do the same process again. All right, so we get this to be x to the 4th plus 3x cubed. And then I'm going to distribute on the minus 4x squared. So we get a negative, and actually this is a little, sorry, this is x to the third. Okay, and then we have negative 4x squared that we're going to distribute. So we get negative 4x cubed. Negative 4x squared times 3 is 12x, negative 12x squared. And then from there, we're now going to distribute this last 4x. Okay, so now when we go ahead and distribute all of those pieces, we're now going to combine our like terms. And so we'll get x to the fourth. I'm going to do y equals here. And then 3x squared minus 4x, or 3x cubed minus 4x cubed will be negative x cubed. And then negative 12x squared plus 4x squared is negative 8x squared. And then plus 12x. And this would be our final answer for standard form. So that didn't finish graphing, obviously. We multiplied it out. A few things that we can see, and we could have seen this before too, but it's a degree 4. The leading coefficient is 1. So we know it's going to make some sort of like W shape kind of going on here. The y-intercept, there's no constant term, so the y-intercept is going to be 0. And then the x-intercepts, I can pull right from my equation. So at the beginning, so I see I have 1x here, so my x-intercepts are going to be 0, a positive 2, that's a double root, and a negative 3. So when I go ahead and graph this, I kind of know some, it doesn't have to be perfect, but there's some things that I already know, right? I know I'm going to have roots at 0. I'm going to have a root, if I go 1, 2, 3, 4, maybe here. And I'm going to have one at 2. And I'm going to have one at, let me do 1, 2, 3, 4 here. I'm going to have one at negative 3. Okay, so I have these 3 roots here. Now maybe do the little highlighter here. Okay, so we know that these are going to be our 3 roots. We also know that our y-intercept is at 0. It's going to make this like L shape kind of going on here. And then also the last thing is we know that 2 is going to be a double root, right? So we know that it's going to hit that and bounce. So now what we're going to do is do our best. I know it starts up here, so I'm going to go maybe down. Maybe going to go up. Maybe going to hit here, and I know it's going to bounce. And just kind of do my best to make like that W shape, knowing it has to bounce onto the y-intercept is also 0. And this would be how we would do a sketch of that graph. The example 2 is basically the same type of problem. This time we're given the roots and a leading coefficient. So if we go ahead and write this out, if I want to do my equation first, whatever the roots are, I know I'm going to set it equal to, it's like setting it equal to 0. So I'm going to have here x plus 2, x minus 5, because I'm taking the opposite sign here. And now we're just going to go ahead and multiply it out. If I want to distribute the 2 first, I can because there's no parenthesis there. And nothing really too different. It's just, again, just a little tedious, but same thing as before. So I would get here 2x squared minus 10x plus 4x minus 20. 2x squared minus 6x minus 20. And few things we kind of know here. We already have our roots, so the x-intercepts are at -2 and 5. We have 2 intercepts, so we know it's a degree 2. But we could have seen that from our multiplied out. Our leading coefficient is a +2. So we know it's roughly going to make this the quadratic shape that we're kind of used to. And then our y-intercept is at -20. So if we want to try to sketch that, might help a little bit. And then that's all we really have to do for this problem. So I go to -2. I'm going to go to +5. I know that I have a y-intercept maybe of -20. I'll put that down here. And then just do our best to kind of sketch what that looks like, right? So I know it's going to make that U shape with an even degree, so it's going to have the end behavior in the same direction. All right, for number 2, it's again same thing as before, so I'll kind of even skip through the multiplying part because it looks very, very similar. So we're given here that we have a leading coefficient of -1, and our roots, I'm going to take the opposite sign. So when we multiply this out, it's going to be the same thing. So if you want to try to see if you're getting it correct, your final answer should be -x cubed plus 7x minus 6. A few things we kind of note here. We already know the roots, right? So those are our x-intercepts. Our y-intercept is -6. It's a degree 3. And the leading coefficient is a -1. So if our usual x cubed looks something like this, we know that with a -1, it's going to be the opposite direction, right? Because it switches that direction. So when we go ahead and plot this, I'm going to maybe plot a -3. I'm going to plot a +2 and a +1. And maybe I'll plot my -6 down here. Okay, and then we're just going to do our best to kind of go through these points, knowing that it's going to kind of follow this direction here. So maybe we'll do something like this. So starts from up here. And looks something like that. In example 3, we're writing equations from the graph. So we can first identify the degree and then use it to get the equation. So algebraically, very, very similar to what we've been doing. We're just reading it off a graph. So when we go ahead and do this piece here, if I take my intercepts for number 1, I see I have an x-intercept of -1, 0, and 2. So I'm going to take the opposite signs. And then I have x minus 0 is just x, so I can even tack that x out front. And now we're just going to multiply this all out. So when we go ahead and multiply it, if you wanted to check, because again, it's kind of a tedious process, so you can check to see if you're multiplying it correctly. That's usually what ends up happening. It's the same process, but we make like little mistakes. So if you multiply it out correctly, this is what you should have as your equation. And you can see it's a degree 3, so that checks out. The y-intercept is at 0, so that also checks out. And if we multiply it again, we would get x cubed minus x squared minus 2x. The last one here, you can see this is a degree 4 because even though it has only 3 intercepts, the middle one is kind of like where it bounces and it makes like a double root. So this is a degree 4. If I list this out, I have x-intercepts at -2. I have 0, but it's a double root. And I have 1 at 2. So if I multiply this out, I might write that 0 first, and it's a double root, so I have to put a 2. The opposite sign, x plus 2, x minus 2. And if we multiply that out, and again, you can multiply it and check your answer, you would end up with x to the 4th minus 4x squared. So even though it has all those roots, it only ends up being 2 terms at the end, degree 4, and a leading coefficient of 1. If you have any questions, you can sign up for T-Bolt time, get help in the center, or ask questions during class.